Okay, so homework assignment for today was Blackjack, right? How'd that go? Easy? Easier than easy?
For you.
Well, it wasn't easy. It was terrible. Is this the worst one yet?
No,
What was the worst one so far?
I think the first game,
Before we
Connect
Connect Four was the worst. That was just last week.
4.
So I made the next assignment easier, but this was still bad.
That's pretty bad.
Oh my gosh. All right, let's take a look here. So I meant for this one to be easy.
But the jump start we gave us is pretty
So you got it done. It was just challenging. All right. All right. Lock this stuff. We are. All right, so there's our card, there's our deck, there's our driver. Players, that was when we first introduced objects. Okay, so I'm gonna, that's fine. So we have a card, deck, and a driver. So what I did last time is we saw that a deck is a collection of cards. So we went through and in the constructor for deck, we went ahead and filled it up with all of our cards. Then we told the guy to shuffle himself, and what did we do? We just swapped two positions 5,000 times and said that's shuffling. And then we tell the deck to go ahead and display itself. Now, we did do some designing last time, right? For Blackjack, we had a dealer, which has the dealer is maybe going to have a deck of cards, and he's going to shuffle that deck, and he's also going to deal the cards. We already have the deck. We already have the card. We might need to make a little adjustment to our card to handle the aces or ones or 11s, but everything else should be the same. We're going to need a player. This is the interface with us to show us the contents of our hand and that kind of stuff. So what's a hand? It's a collection of cards. Starts off with 0 cards, have to have the ability to put some cards into the hand, that kind of stuff. All right, so let's go ahead and let's kind of build some of these extraneous pieces here. Let's build hand first, okay? Because hand's going to be pretty simple. It's just going to be a collection of cards. Going to start off with no cards, and it has to have the ability to add things to our hand, right? We need to be able to, if we think about this, I'm a player, I'm holding a hand. Somehow a card is handed to that player, probably from the dealer, but for right now, somehow a card is handed to that player. The player puts it into their hand. Okay, so it inserts it into their hand. So let's go ahead and build a hand. That's this guy right here. New class hand. All right, and we decided that a hand is going to be a collection of cards. All right, so if we want to have a collection of something, right now our go-to move is an array, correct? How many cards does our, what's the maximum number of cards that we might have in our hand?
12.
12? Okay, so any more than 12 and we've busted? Is that the deal? Okay. Now, it doesn't really matter what we put in here if we want to decide that our hand can hold potentially all of the cards. That way, this guy is maybe more useful as a generalistic object for all sorts of different card games. We can do that. So we can say private, let's call this the cards, is going to be a card array. And then we'll build our constructor for hand. And we'll say this dot the cards is equal to a new card array, size 52, just as a worst case, let's say. And oh, wrong language. There we go. All right, now we probably also want to keep track of how many cards we currently have in our hand. Okay, because right now we have this giant container built for holding a whole bunch of cards. Now, as the dealer hands us a card, we're going to say, oh, I have one card now. I have two cards now. I have three cards now. We want to keep track of how many cards we actually have in there, right? So we'll have a private int, call this guy card count. And we'll say this dot card count. We'll start off at 0. Now we're going to need to have a public method to add a card to our hand, right? So adding a card to our hand, the very first card that we add is going to go into position 0. Next one will go into position 1, position 2. So we'll put it into position card count. So we'll have a public void add card method. This guy will take a card C as a parameter. So this is like the hand being handed a card and us putting that card into our collection of cards. So we'll go ahead and say this dot the cards at bucket this dot card count is equal to C, and then this dot card count plus plus. We put it into our hand, we increment the number of cards we currently have in our hand. Make sense? All right, and then for right now, let's go ahead and have a way for a hand to display themselves. So we want to display all the cards inside of our card array between bucket 0 and bucket, well, card count, right? -1 is what it'll end up being. So we'll say for int I is equal to 0, I is less than this dot card count, I plus plus. So if card count is currently 0, we have no cards in there, no cards to display, and this won't display any. But as long as we have at least one, what are we going to do? We're going to say this dot the cards at bucket I dot display. So when we ask a hand to display itself, it's going to go through all the cards in the hand, telling each of those cards to display themselves. Make sense? Okay, so let's kind of leave this guy like this right now. Let's test this. So here we have our deck, and we shuffled the deck. Do we have a way of getting a card from the deck yet? We don't. So let's go ahead and build our dealer then. Our dealer knows how to grab cards from the deck, so let's get him fleshed out. Actually, we're going to need to be able to get the top card from the deck, correct? You know, that's something we need to be able to do. So why don't we just let decks know how to do that? So we'll say public card get top. Okay, and that's going to return the card at the top of the deck. Well, as we start returning cards from the top of the deck is going to change, right? So we're going to have to keep track of in deck the top. And when we first build our deck, the top will be at bucket 0. When we shuffle the deck, we'll reset the top to 0. When we get top, we're going to say card to return is going to equal this dot the cards at bucket this dot top. Then we'll say this dot top plus plus, so it's going to walk down the list. And then we'll say return card to return. Now, technically, right now we have no stop here that says if we try to deal 57 cards or something like that, our program will crash because we're going to be returning a null value and probably trying to use it someplace else. But for right now, functionally, as long as we don't hit that many times, we should be fine. Okay, so we'll go ahead and grab the card from the top of the deck. So we have it ready to return. Then we increment the top of our deck. So the top of the deck is no longer at position 0. The next card to be dealt will actually be position 1, then position 2, then position 3. So that's where I'm incrementing that, and then I'll return the card to return. We have to do it that way. We can't just return this value without doing this. Because when you have a return statement, a method immediately ends. It's over, okay? Now, when I first showed you the plus plus operator, remember we talked about plus plus coming before versus coming after? And I said it's always it's never wrong to put the plus plus on a line by itself. Let me show you an alternative to these three lines. This line right here is equivalent to all three of these lines. So it takes advantage of that. Let me go ahead and just to kind of show you a real life example of when using that plus plus operator in line is helpful. In this case, I know the return statement makes a method immediately end. I also know that when I have the plus plus following a value, I get the current value of it first, and then it increments later. So this one line will ultimately end up returning the card at the current top of the deck, and it will also increment top by 1 after that. Does that make sense? So this might be what the cool kids would do, but I'm sure several of you at least find this line confusing. And at the very least, you wouldn't trust yourself to write it. It's there's a lot of moving parts to that line. This solution is perfectly acceptable. There's nothing wrong with it. All right. Here's the card I'm going to return in a second. Now I'm going to do the crap that I want to do before I return it. And finally, I'll actually return it. It's fine. I would write it this way. That's how I would personally write it. It's clear. Anybody who looks at it can read it pretty well. Whereas if you have this line, it requires that whoever's reading it understands the difference between plus plus coming before and plus plus coming after. Make sense? All right, so this guy will get the top of the deck and then increment where the top of the deck is. So if we want to test this out here, come out to our driver, we create a deck, we shuffle the deck, which resets top to the top even though it's still already at 0. We'll go ahead and display the deck so we'll see what's currently there. Now let's go ahead and build a hand. And then we'll say h dot add card. What card are we going to add? D dot get top. And then let's do that twice. All right, and then we'll go ahead and say D dot display. Put a little separator there so we can see where the printing out the deck ends and printing out our hand starts. All right, so we'll have a shuffled deck up here. We'll prove it by displaying it. Then we'll create a brand new hand. We'll deal the top 2 cards off the deck, putting them into our hand, and then tell our hand to display itself. And the top 2 cards that are, our hand should have the top 2 cards that we see when we displayed our deck originally. Okay? So top 2 cards are King of Clubs and Queen of Clubs. And here's the King and Queen of Clubs in our hand. Make sense? And if we were to deal another card, the next one off the top of the deck would be that guy. 3 of spades, so on and so forth. All right. So now we have a way of getting values into the hand. Now, generally speaking, if we're sitting around at the card table, unless there's a magician present, we typically wouldn't just be watching the deck float cards over to the hand that's laying there, right? There's kind of people involved usually. All right, so we want to bring some other players to the table. Some other, a lot of times, kind of beginning programming tools call them actors. We think of our game as like a scene. We're watching the Blackjack scene in a movie. And who are the actors on stage? Well, there's a deck of cards. There's some players. There's a dealer. All those people are there. There are objects in our object-oriented solution to the problem. That makes some sense? All right, so let's go ahead and make a dealer. And we'll have the dealer hold on to the deck. And then we'll have the dealer deal a card directly into the hand. Take this one little step at a time. Now, one thing I want you to kind of notice as I'm doing this is notice that I am kind of letting the code organically grow, right? We're doing this one step at a time. We're thinking, oh, well, what comes next? Almost like we're putting on our own little play. Now, when you're doing this at home, you should probably plan it out a little bit more strictly than that. Okay, I've been doing this for a bit, so I can kind of shoot from the hip on problems this size. But if I'm approaching a really large problem, okay, I will let aspects of it organically grow, but you want to think about the problem first. Okay, so everybody has their tipping point where they got to start drawing their pictures. Okay, I could write Blackjack all right, I think. So we're going to write a dealer. Okay, because we have these pieces, we got this deck sitting there, we got a hand sitting here, and who's going to use these? It's really the dealer that holds the deck, and the player holds the hand. All right, so we'll be able to build a dealer here. All right, and the dealer is going to have a private deck. We'll call this guy the deck. And then here's the constructor for dealer. And he'll say this dot the deck is equal to a new deck. All right. Now, the dealer should have the ability to shuffle a deck, as opposed to being born. Let's just think about this from an object-oriented perspective. If every single time we want a deck to be shuffled, the dealer is born and then creates the deck and tells the deck to shuffle, like this. And then let's say we have a method called deal, and this guy returns this dot the deck dot get top. All right, so a dealer, when he first comes into existence, builds a deck, shuffles the deck, and now he has one ability to deal a card. Okay, so now what we can do out here, before I show you the example I want to get at here, is I'll go ahead and we're going to get rid of all that. We'll say dealer D is equal to new dealer. And then we'll say D.deal. D.deal. Because that's what dealers do. They deal. Right? Just so happens that's an abstraction for getting the top of the card from the deck that the dealer controls. There's no new logic there. We've just hidden that thing. Like, what does it mean for the dealer to deal? Well, he takes the deck and he takes the top card off it and he hands it to you. That's what he does. So we've encapsulated that logic inside of this method, which lives inside of the dealer class. So when we're looking at them acting out on stage here, out here in driver, the dealer walks onto stage and he deals a couple of cards. How he's pulling that off, the details of it aren't important to us. Only the public interfaces are shown. Okay, remember way back when we talked about the object-oriented telephone versus the procedural telephone? And we said the procedural telephone looks like a big pile of wires. Object-oriented telephone looks like a telephone, but only the public interfaces, the parts of it we actually need to work, are exposed. So for our dealer here, what we really need out of a dealer is we need him to be able to hand us a card. We need him to be able to deal. So we've exposed that method as a public method. That's what a dealer knows how to do. He knows how to deal cards. How he accomplishes it from the programmer's perspective is important because we had to write it. But from whoever is sitting at the card table, sitting across from the dealer, they don't care how he's pulling it off. You know, different dealers, they shuffle cards differently and all sorts of stuff. But, you know, all we care about is that we get a card from them. All right? Now, the way this is built right now, the dealer is born right here. We call it, when we say an object is born, we call it it's instantiated. Go ahead.
Is there any reason that we have to use abstraction?
Is there a reason that we have to? No, there's not a reason you have to use it. There's a reason that you should use it. And that's because as problems become more and more complex, the fewer details that are exposed, the easier we're going to be able to solve the problem. Because there's aspects of the stuff that we don't need to deal with a majority of the time. You know, so just like going back to the procedural versus object-oriented telephone, there's not a great reason that we have to stuff all those wires into a pretty box that looks like a phone. We don't have to do that. It worked without doing that. But why did we do it? Because it's better, right? You know, if we're the people using that phone, we only care about a couple of the features. We don't care about the 4 zillion wires that are in there. That's somebody else's problem, right? In this room right here, you know, we're surrounded by drywall on these walls. Do they have to be there? Or is it just a nice convenience for us to be able to hang pictures on it? It's not going to hurt anything if we have wires. Actually, the walls are probably, they're probably not drywall, actually. They're probably cement walls because we have the conduit coming down with the power. So they probably can't get inside those walls. But regardless, the point is that the wires and things that might be hidden in here, that's only for our own eyes to hide it. They'll still work if they're not hidden. They just won't, it won't look good, right? Okay, so, you know, I guess that's the answer to your question. It's human nature to want to have clean solutions to things and only have to deal with the details that we care about.
So it has nothing to do with security or protection.
Security goes that's a whole different argument, because if you're writing the application entirely yourself, security doesn't mean anything. If you're writing a bunch of objects like this that you intend to distribute and let other people use to solve their problems, well, then you might want to be a little bit more particular about what things you give them direct access to versus what things they have to kind of go through a gatekeeper to get to, go through a public function that protects the private members. That's where getters and setters kind of come in. So security is involved, but not really in this case. In this case, we're just trying to keep things as simple as possible. And what I'm trying, most of you in here, I hope, made an attempt to make your project as object-oriented as possible. You tried to create objects. But most of you are probably also going to sit in class today and say, oh, well, I didn't do that. I didn't take it that one extra level. That's okay. You know, this is just in the moment my take on the object-oriented version of this. Okay? But notice here when we come back out here, we're creating a scenario. A dealer has walked up to the table. Okay? There happens to be a hand sitting there at the table with a currently invisible ghostly figure holding it because we haven't written the player that's holding the hand yet. Okay? And the dealer deals a couple of cards to that hand. This is seemingly, as we keep adding stuff, seemingly becoming more and more realistic. Now, is there anything, so getting back to your point, is there anything that says it has to be realistic? It doesn't have to be realistic. I mean, we can write it. We can build our telephone out of wires if we want to. It's fine. You know, it might be inconvenient for a lot of people to use, but we're only building it for ourselves. Who cares? Right? Okay, so nothing says it has to be written this way, but understand that the purpose of object-oriented programming languages, well, the purpose of a programming language in general, going way back to the beginning of the class, the purpose of language in general is to teach us, or is to give us a tool that allows us to solve problems the way we already solve problems. All of us are really, really, really good problem solvers. Okay, we're good at this stuff already. The programming language gives us a tool to leverage what we're already good at. Object-oriented languages further that power tool, and they say, hey, we recognize that human beings already solve problems in terms of objects. You already think about things around you as far as in terms of things. This is a thing. This is a thing. These are both objects, okay? Anything that we say is a thing is an object, okay? Now, this particular object has different properties associated with this object. Okay, this guy is a remote control that probably controls something. We look around the room, we kind of figure out it probably controls that guy, but at the very least we can identify this as a remote control, and we suspect that the buttons that are on this, the public interfaces each one must do something, correct? Well, we know this guy's a phone, and we realize that this guy has a different function to this guy, but they're both things. That makes some sense?
outsider, I can manipulate the card on top on method in hand, right? Because it's public.
So, say this again.
As an outsider, I can manipulate the method in hand, top card method in hand.
Hand doesn't have top card.
I mean, the deck.
Deck, it's private. I intended to make it
Outsider,
private.
I can manipulate the method, right? Because it's public.
It's not public.
No, the method, card on top.
Well, the method's public, so if you happen to have access to the deck, you can grab the top card. Isn't that true to life?
Also, I can manipulate the method because I can change the value of the top variable inside the method. Right? Is there any way I can make the method private and still access the method?
Yes, but you know how to. Yes, but it really wouldn't make sense here. You'd have to do it through inheritance. You wouldn't make it private. You would make it potentially protected. But this is the point you're making, though, breaks reality. I'm kind of encouraging to solve problems like in real life. If there's a deck of cards sitting here, any one of you could walk up to that deck of cards and take the top card off, right? That's allowed. That's it's not like the thing is some sort of electrified trap, right? Any of us can walk up and take the card off the top of the deck, which would then change the top of the deck. It's okay. That's allowed. That's making that deck act like a deck of cards. So that's how ours acts. All right. Now, also that when you talk about security and things like that, you only want to take that argument so far depending on what you're building. We're building a text-based blackjack simulator. We probably don't care about security all that much. We care enough about it from an academic perspective that, well, we don't want to completely be, idiotic about this, but at the same time, we're not worrying about, Russian hackers dealing with our Java blackjack game. All right? We're a little loose on the security. I think it's going to be all right. So we really want to use this as an opportunity to practice object-oriented programming. All right, so we got our dealer. We have our hand. The dealer deals some cards, and we expect that to, the dealer's holding the deck of cards. He deals a couple of cards. Now that deck of cards has 2 fewer cards on it, even though in our implementation there aren't any fewer cards in the actual deck. We've just kind of ticked past the first 2 so that we won't use the top 2 again. So we've kept track of where the top of the deck is. We haven't actually removed those cards from the deck. We could, but we didn't have to. Okay, so then we tell our hand to display itself. Now we want to probably go ahead and have a card player object. This is the person who is going to be playing the game, right? And they're going to have a hand. So a card player, I'm saying card player because we already have a player guy down here. Are we using him for anything else? This is just our first example of an object, right? Yeah, we'll gut him and reuse him. Oh, wait a minute. Yeah, I think we're okay. Because a player was not part of any of our other games, right? Yeah, we're okay. All right, so a player, as opposed to a dealer controls a deck and can deal cards. A player controls a hand and can receive cards, and they can also communicate with the player, well, the person, the human, telling him whether or not I want another card or something like that. But we're going to say a player controls a hand because I'm a player here at the blackjack table and I'm holding on to a hand of cards. So that's what this guy has. So we're going to have a private hand. We'll call that guy the hand. Then public player. And we could choose to give players names and stuff like that. But in this case, we don't need to go that far because it's only going to be a 1-player game. And we'll say this dot the hand is equal to new hand, and that'll go ahead and instantiate our hand. So this actually builds us a hand object. That's where a hand object is actually born. The programmer lingo would be that's where that hand is instantiated. We created the instance of the hand object, and we pointed to it with this variable. Okay? So right there, a hand exists. So now, we'll have a public void let me call this guy take card. So as a player, when I take a card, I'm going to add that card to my hand. Does that make sense? So one of the abilities a player is going to have is to take a card. Here's the card we're taking. What are we going to do with that card? We're going to add it to our hand. Whatever that means. Okay, we wrote add card for a hand already. All right, so now we can come back out here to driver. Now we don't have hands like that. We say player P is equal to new player. And we say P dot take card D dot deal. P dot take card D dot deal. So we'll go ahead and deal 2 cards to the player. Now, a player should be able to show their hand. If we're thinking about a blackjack game when they've said we're done, right? The game's over, and they're going to reveal their hand, they're going to show their hand, right? To say whether they were bluffing or not, right? They show their hand. So one of the abilities a player is going to have is to show their hand. That's going to be a public ability. And in this case, we'll say this dot the hand dot display. We're eventually going to be putting some score type stuff in there. But for right now, when we ask a player to display to show their hand, they're just going to ask the hand that they have to display itself. Okay? So this is where we start blurring reality a little bit, right? Because we would think it's kind of weird if we're sitting at a card table with somebody and a player sitting there and he's starting to talk to his hand of cards. He's got three cards in his hands. He's speaking to it. It's like, all right, it's time for you to display yourself. That's when the people with the coats come in, and right? That's not normal. But object-oriented programming, that's normal. It's normal for us, all right? But we didn't have to write it that way. All right, so we'll ask our hand to display itself. So now we'll go back out here. After the player took a couple cards, we'll say player dot show hand, and we'll see basically the same output we've had before. Okay? But every iteration, this is becoming more and more normal looking, right? A player and a dealer walk up to a table. The player takes 2 cards from the dealer. The dealer deals those 2 cards to the player. Then the player shows their hand. It's starting to sound like a game, right? Okay, because of the way we're encapsulating these details, we're abstracting the solution of this problem into these objects. Okay. Now, something we're probably going to want to do here is we're going to want to kind of wrap all of this inside of a game object, right? Maybe called Blackjack. And when we tell Blackjack to play, that's when the player comes into existence. We're all right now. We might have a perpetual, if you think about a casino, there might be a perpetual blackjack table that always has a dealer standing there. And then players come and go as the night goes on. But for us right now, we're going to assume that a game of blackjack involves a dealer and a player. And when we create the blackjack game, a dealer and a player are created at that moment, okay, for our version of this. We'll do a new class. Call this guy Blackjack. And this guy's going to have a private dealer called the dealer. It's going to have a private player called the player. Public Blackjack. Here's the constructor. We'll say this dot the dealer is equal to a new dealer. This dot the player is equal to a new player. Now, something I was going to point out earlier, and I got off track a little bit, is here inside of dealer, When the dealer is born, he shuffles the cards. Now, that probably doesn't make a ton of sense. In our game right here, it's probably okay because we're playing a single-person game or something like that. But at the end of a game of blackjack, when that dealer is done, when the game is done, if you want to play another game, like, oh, you want to play another hand? Right now, the dealer does not have the ability to reshuffle their cards. Because they only shuffled the cards once when they were first born, when they were first instantiated. So what we might do is we might say that a dealer has a shuffle method that calls the deck shuffle. So with that in mind, what would happen here is if we were inside of the blackjack game, after we created the dealer, it could be after we created the player too, but after we created the dealer at some point, we would say this dot, the dealer dot shuffle. So we would tell the dealer to go ahead and shuffle the cards. Okay. Now, we're probably going to have a public void play method, which actually starts to play the game. Maybe that's when the dealer shuffles the cards. Maybe he doesn't shuffle when blackjack is first born. Instead, when we say play, the dealer shuffles the cards. And now we're ready to play. Go ahead.
Inside the dealer, we shuffle the cards inside the constructor, right?
Originally, I did.
Yeah, so
Now I took it out of there.
Yeah.
Now a dealer is standing there with a brand new deck of cards that they just unwrapped. All the cards are in the factory order, right? Not shuffled at all.
Okay, let's assume that we still have the shuffle inside the constructor, and we are creating two instances of dealer, like one inside the hand and the other one inside.
No, there's no dealer inside a hand.
Then how is he taking the
Well, right here's my dealer,
card? Yeah.
here's my player. I'm telling my player to take a card from the dealer dealing the card.
So we are creating two instances of dealer inside the driver and
No.
one inside the
Well, yeah, but we're upgrading this. We're going to be moving this stuff into blackjack.
The point is, whenever we create an instance, we are creating totally new set of objects, right?
Correct.
So
So if I was this dealer, if I'm this guy, and then we're playing the game blackjack,
there's a different.
this guy right here, that one's you. Okay, you're the second dealer.
So whenever we create an instance of the dealer, we are shuffling it again.
No, not right now, because dealer,
We are still assuming that.
it's not doing it in the constructor.
We are still assuming that the shuffle is inside the constructor.
Well, you can assume that all you want, but that's not how we wrote it.
So what if I just want to create an instance of an object and use the same instance for all other classes? Can I do that?
Sure, you'd have to pass it in. I mean, you would have to, if we had a blackjack game that we created, and then we had a dealer over here, we said, okay, well, we want this blackjack game to be run by this dealer. We would, in the constructor for this guy, we'd pass the dealer in. Instead of having him create a new dealer, we'd pass the dealer we want to use. Just passing pointers around. So, I mean, for example, maybe we don't do this here. Instead, we pass in the dealer for this blackjack game. So now what we can do is out here in driver, we have our dealer. And now the constructor takes in the dealer for that game. So now this same pointer was passed into this instance of blackjack and was set equal to the dealer for that game. So now we still could use that dealer for other things if we want to. But now you have a problem, okay? Because I'm a dealer. I'm just thinking out loud here in this specific instance. If the blackjack game that's being run over there has already dealt 5 or 6 cards, And then I come over here and I deal a couple cards to somebody else. My deck is in a different state than it would be just from this game. That's typically not allowed at casinos. In fact, a lot of times at casinos, a single game is playing from like 4 or 5 decks simultaneously. That way, people have trouble counting cards and that kind of stuff. Okay, but a variable is just a variable. It means that you don't have to make it any more complicated than that. If you have this dealer out here and you want him to be able to be used in multiple places, you pass it to those places. And you can use it there. Then you just have to ask yourself, should you?
So I took an approach where I had to create instances of hand twice, and whenever I create an instance of a hand, I'm getting 2 different values. That is why I had this question.
Okay. I would have to see how you're creating your instances, but I'm sure it's because you have 2 different instances and you have 2 different pointers, therefore you have 2 different values. They're pointing to different hands. All right, so our blackjack game, when we first create it, is going to instantiate the dealer, instantiate the player. The blackjack game is going to have a public ability called play. The very first thing that happens before we start playing blackjack is the dealer goes ahead and shuffles the deck. Whether it was already shuffled or not, I mean, for instance, it's not hurting anything if we come in here and say the deck.shuffle. If you want to make sure that all dealers always start off with a shuffled deck instead of a deck that's all in order in case somebody forgets to shuffle it, you could do that. It's not going to hurt anything. The worst that happens is you shuffle twice. That make sense? Okay, it's just not necessary in what we're doing here because I'm kind of thinking about the game blackjack. It doesn't matter what the current state of the deck is. When you start a new game, you shuffle the deck. That's like the first thing you do when you start a card game is you shuffle the deck. All right, so we don't need to put that there, but it wouldn't hurt anything. A couple of, microseconds on the CPU to swap things 5,000 times. Sounds like a lot of work for a human, but computers, it's not a big deal, right? All right, so when we hit play, we're going to go ahead and shuffle the deck, and then we're going to go ahead and deal 2 cards to our player. Right? That's how blackjack starts. Okay, I'm a player. When the game starts, I have no choice but to take 2 cards from the dealer. Correct? All right, so the very first thing that happens, I say, this dot, the player, dot take card, this dot, the dealer, dot deal. And we'll do that twice. All right, so the player takes 2 cards. The dealer deals 2 cards. That's what happens right at the beginning of the game. So as of right now, the player has 2 cards in their hand. And what we want to do is we want to show those cards to the player and then give the player the opportunity to get another card. Does that make sense? So let's, for right now, just put a nice little infinite loop in here, while true. So forever, we're going to keep showing them their cards and ask them if they want another card with no way of escaping. All right, we'll put in a way of escaping here in a second. But is this a Boolean expression? What's a Boolean expression? Any expression that boils down to a single value of true or false. Is that a single value of true or false? Sure, it in fact is true. By definition, that is a Boolean literal. He is a Boolean expression. We just didn't have to do a whole lot of work to get to it because he was already a Boolean literal. This is an infinite loop. A loop says, while whatever is in here is true, keep doing this stuff. And the Boolean literal value true is always true. So this will never end. Yeah, we're not going to leave it like this. This just gives us a nice, convenient, instant loop where we don't have to think about any logic. We just want to keep asking a question multiple times. All right, so we can kind of see the mechanics of this. All right, so what are we going to do inside of this loop? We're going to first show the player's hand. Here's the current hand I have. Right? So we'll say this dot the player dot show hand. Then we want to ask the player, do you want another card? Now we're going to have to throw the value stuff in here in a few minutes, but for right now, we're asking the player, do you want another card after we've shown them their cards? So we're going to prompt them, system.out.print, do you want another card? And then we need to read that answer in from them. In order to read something in, we use the scanner, right? So we'll go ahead and build our instance of scanner up here. Scanner input is equal to new scanner system.in. And we need to import java.util.scanner. Brought it up there. That way we have access to that object, because that guy doesn't live inside of the core Java language. The core Java language is inside of something called java.lang. So without us doing anything, this line is always there. Import java.lang.star. So that says all the base core Java stuff is available to you in all Java programs without you having to do anything special. Well, there's this other library called the util library that has some other crap in it that we might want to use. For instance, the scanner or the random number generator. Okay, some of the tools like that we don't want to bloat our program down by having, an entire garage filled with tools that we're never going to use. So Sun Microsystems, now Oracle, decided, okay, here's the core language stuff that you really always need. This is the stuff you need access to at all times. This is your bare minimum. But if you want to use some of this other stuff, you can go ahead and just bring it to the job. Bring it to the work site. All right. So we had to specifically import the scanner here so that we could use it. And system.in is the standard input stream, which is our keyboard. We would also use, we can use a scanner to read stuff in from a file, just we wouldn't use this input stream. We would use an input stream associated with a file. We haven't done that yet, but after we've done that, we use scanner the same exact way. To read from a file, we say next, or next line, or next int, all the same thing. All right, so do you want to enter a card, or do you want another card? So let's go ahead and say string answer is equal to input dot next. Okay, and this should give us whatever the answer is. Maybe we give them kind of the choice y/n or something like that. That's what we expect them to type in. So we go ahead and get our answer. And then if answer, I'm about to trick you. If answer is equal to y, then we'll say this dot the player. Actually, we'll just steal this line. The player will take another card from the dealer. Is that going to work? Remember us talking about this before?
So we tried that condition yesterday, but it didn't work. I don't know why.
I'm not talking about the condition you wrote yesterday. I'm talking about my condition I wrote today.
Yeah, we tried the exact condition.
I bet it wasn't exact if you're answering incorrectly. So is this going to work? We're reading in our answer, so we're going to type something in here, right? Answer, we're asking, is answer equivalent to y? What is this guy asking? It's asking, does this string point to the same place as this string? It's not comparing their contents. Remember when we talked about the string literal thing that we might have down here? So when the string literal y was created, it gets put somewhere. Now, there's two possible outcomes here. You're telling me that this won't work if your solution was identical to this, all right? If we assume that you're right, that it's not going to work, what does that tell you about this guy? It tells us that when we call the next method on our input, that it doesn't read in a string literal. Instead, it reads in a new string. It's building new memory to store what the user typed in, which means if we ask the user for input and they put in the number, they put in yes 10 times in a row, those are 10 different yeses. They don't all point to the same yes in literal memory. All right. Now, so let's see. You're saying it's not going to work. I suspect this will work. Okay. But if it doesn't work, it's for the reason that I said. It's because this guy must be generating new memory for every input, which is perfectly reasonable. All right. So.
Doesn't the double equal sign mean that exact same string?
Exact same memory address. Yeah, it's not comparing contents. So what you said is correct, but I think the way you're thinking about it is wrong. It does mean that exact same string literal, but not in terms of its contents. It means it's several of you might have an iPhone, but only I have this particular iPhone, right? Somebody else in here might have the identical model and everything. Looks identical, has the same version of the software on it, but it's not equal to this. It's not equal to this one. It's dot equals to this one. It's the same kind of iPhone. Does that make sense? Instead of it being a whole separate thing, because this one's up here by me. All right, so let's go ahead and test this. So we'll go ahead when we have to actually play the game. So here's our blackjack game. We don't need a dealer anymore because the blackjack game creates that. We'll say game.play. All right, and when the game goes to play, what happens? Well, the dealer shuffles a deck. We hand the player a couple of cards. Then, forever, we show the player's current hand. We ask the player if they want another card. And then we look at their answer. If they type in a Y, we give them another card. Then we spin back up and show them the hand again. If they don't type in a Y, we just show them the same hand they just saw again. Forever. This while loop never ends currently. Okay. Let's go ahead and write this or run this. So there's my two cards. So I have a 6 and a 5. Do we want another card? Let's go ahead and say capital Y for yes. So you're saying this will not give me another card. Okay, I suspected it would. Okay, it did not give me another card. So that tells me that this guy right here is giving us new memory. Brand new memory. Now, regardless of what the answer ended up being, this is actually a good lesson both ways. It tells us that if I want to compare the contents of a string, we don't use the double equal sign. That's not the way to look at contents. All right, we use the dot equals method to check the contents of two strings. Then the memory address doesn't matter. It doesn't matter if it's this string Y being equal to that string Y. If we're using dot equals, they could be the same because we're not talking about the same physical string. We're talking about them containing the same thing. Like me asking how many of you have an iPhone 7 Plus. Whoever does, that means that your phone dot equals my phone, even though they are physically separate phones. They're the same phone, right? So we're going to say answer dot equals, and let's use the ignore case version of this. That way it doesn't matter if they put in an upper or a lowercase y. So if answer dot equals ignore case, so y, then we'll go ahead and give them another card. Run this. Do you want another card? I'll do a lowercase y. There's my other card. Things have gone south quickly in this particular hand of blackjack. We have a 29, and there's no bluffing past this one. We are dead in the water with this one. All right, and then it's just going to keep us at that current thing. We'll do a capital Y, and at this point we don't have any logic in there. It keeps us from getting new cards, so it just keeps going. Whoa, 39. We could have invented a game here called double blackjack. 39 when you're trying to get to a 42. That's not bad. All right, so does that make sense with the string literal stuff? Rule of thumb would be You never, ever, ever, ever have to remember that double equal sign thing. In this particular case right here, he was right. I was wrong. Because to my knowledge at least, I'd never investigated what that guy gives us. It's a reasonable assumption to think he's going to give us the string literal that was typed in. And if the user types in Y 5 times in a row, it's giving you a pointer to the exact same Y. Seems to make, sense from a memory efficiency perspective. But that's not how it works. It gave us new memory. So it gave us a Y that lives there, another Y that lives there, another Y that lives there, another Y that lives there. So the double equal sign was never going to work. Okay? But that's okay. We never have to be concerned about that if we always use one of the comparison methods to compare the contents of strings and not try to rely on the double equal sign for comparing the pointers. That double equal sign is the primitive equivalence operator, not to be used on objects unless we're comparing their pointers, their memory addresses. In this case, we want to know whether the string they typed in is equal to the string Y. So we use the dot equals function, or now it compares it to Y or uppercase Y. All right, so at this point, we're going to keep handing them more cards over and over and over again until actually right now it doesn't matter. There is no until. So what we really want to do is we want to hand them cards over and over and over again until they press N. Correct? All right. So how do we write this code? We have a couple different ways we can do this. One thing we can do is we can leave this as an infinite loop here and then use our break keyword to dive out of the while loop. Have I shown you the break keyword in here to get out of a loop? Okay. So we can say else here, break. And that will break us out of the most local loop. So even though this guy is always true, this breaks it, artificially gets us out. All right, so with that in mind, we can just say, okay, here, we'll show you the hand, we'll ask you the question over and over and over again until you finally say N. As soon as you say no, you don't want another card, then we'll dive out. Okay? So we'll see that. We'll put a couple of yeses. No, lost again. There's our N. Program's over. Okay, so now what we want to do is we need to have a way of calculating the score for a hand, right? Hands need to be able to calculate their score. And in order to do this, we're going to have to get treat aces as a special case. Aces are 1s or 11s, correct? And currently, I believe, have an ace counting as an 11 in our code. Where's Beck? Yep, so I have it treated as an 11 right now. So when we get the value of a deck, if we are dealing with an 11, that's when we need to branch and give ourselves a new possible value for that hand. Does that make sense? Okay, so let's go to our hand. And let's give ourselves a for right now, let's just do void. We're not going to return the value. Instead, we'll show the value for the hand. So we'll say public void. Let's call it show values because some hands might have multiple values depending on the nature of this guy. Okay, so a couple different things we can do here. Cool kids might write this recursively, which is kind of a fun thing to do, actually. We'll look at that here in a second. But the idea here is we have 3 cards in our hand. We're going to walk through the cards and start summing up the values. But as soon as we hit a value that has an 11, at that point, we now have 2 different possible sums. Correct? We have a sum that treats it as an 11, And we have another sum that treats it as a 1. Okay, 2 different values for that hand. All right. Now, we might have up to 4 aces in our hand. It's possible, correct? We can have up to 4 aces in our hand, which means that we could potentially have a hand with more than 2 values. Because each of those aces can be any of the 2 values. Correct? So how many total values can a hand have? What's the maximum number of different values that a hand can have? Say this again?
21 before it's busted.
I'm asking, let's say a hand has 4 aces in it as well as some other cards. What is the maximum number of values, the number of different values a hand can have? Okay, why 8? Okay, but aren't each of those aces equally? Yeah, it doesn't matter if this ace is a 1 and this ace is an 11 versus this ace being 11 and this ace being 1, right? That doesn't matter, okay? So either all of my aces are 1s, all of my aces are 11s, or some of my aces are 1s and some of my aces are 11s. Does that make sense? Okay, so we can have all sorts of different combinations of those. At any point in time, so if we kind of do this, we have all 4 aces are 1s. That's one possibility. All 4 aces are 11s. That's another possibility. Okay. Then we have 1 ace is an 11, but the other ones are 1s. 1 ace is a 1, but the other ones are 11s. 2 aces are 1, but the other ones are 11s. Then 2 aces are 11s, the other ones are 1s. 3 aces are 11s, the other ones are 1s. 3 aces are 1s, the other ones are 11s. Now we're back to all 4. Where did the 8 come from? You said 8 to begin with. Where did your 8 come from? When we had the 2 aces were 1s and 2 aces are 11s versus 2 aces are 11s and 2 aces are 1s, aren't those the same? So now we're down to 6. Okay, so 6 different values that a hand could potentially have if you had all the aces. Okay, fair enough. So that means we might have to collect a bunch of sums for a hand. Now, whether we sat there and figured out that it was 6 or not doesn't really matter. I'll just create a collection of integers. All right, so I'm going to say I want an int array called values. And this guy is going to be a new int array, I don't know, size 20. It's fine. It's not going to hurt anything. All right. We all pretty...
This is in the condition of how many cards are in one hand.
What do you mean?
Like, I thought at every single point in time, the hand will only have 2 cards.
No, in Blackjack, when you ask for another card, then you become get a third card, or a 4th card, or a 5th card. So you keep adding cards to your hand until you either bust, you're over 21, or you've said, I don't want any more cards because I'm as close to 21 as I can possibly get. So when you take another card, you don't give away a card. Okay? You keep collecting cards. So whenever we call show values, we're going to go through and we're going to calculate our possible values. All right? So inside here, I'm going to say int num values. And as far as we know right now, we're only going to have one value. So we haven't hit an ace yet, right? We're going to have one value. Now, I want to go ahead and I want to fill up my values array with a bunch of zeros. Now, I happen to know that they're already zeros. But if you want to make sure that they're zeros, you want to go ahead and fill them up with zeros. So we'll say for int I is equal to 0, I is less than values.length, I plus plus values at bucket I is equal to 0. That makes sense? Okay. You can also do this. You can say values dot, actually it's not that. It's arrays dot fill values 0. This guy right here does the same as this. So you can either know about the power tool that's out there to automatically fill your arrays, or you just write the stupid little for loop that works anyways. Make sense? So this isn't a big deal. It just takes up a couple lines. So our values array is filled up with 20 zeros just in case we need 20 different values for our hand. Num values tells us how many values we're going to have for this particular hand. And num values effectively is going to be how many aces are in your hand. That's what that guy's going to be. All right. So now we're going to start going through all of our cards in our hand. All right, so we're going to say for int I is equal to, well, actually, we are inside, okay, that's fine. So we're inside hand. So for I equal 0, I is less than this dot card count, I plus plus. So we're going to go through all the cards that are in our hand. And for each of those cards, we want to look at the value. If the value of the current card is an 11, we're going to do something special. Otherwise, we're going to add that number to all of our running total values. Okay? So what we're going to do here is we're going to say if this dot the cards at bucket I dot, that's a card, right? And we need to be able to get the value of a card. So we need to write so we'll do a public int get value, return this dot value. All right, so we've taught a card how to give us access, read-only access, to its private integer value. So if the cards at bucket I dot get value is equal to an 11, that means we have an ace. Do something special. Else, we have something that's not an ace, which the value only means one thing. Therefore, we want to go through our values array this many times and add the current value to each of those running totals. So for int j is less than num values, j plus plus. Notice I'm using j here instead of I because we're currently inside of a for loop that has I. Because what I need to do is I need to go through multiple values inside of my, potentially multiple buckets inside of my values array and add the current value of the card I'm looking at to those. If I had previously seen an ace, I have two different running totals going. So I got to add 7 to this guy and 7 to this guy, for example, to keep both of those totals accurate. So we'll say values at bucket j is equal to values at bucket j plus this dot the cards at bucket I dot get value. All right, so if we're not looking at an ace, update all of my potential values for this hand with the new card number. All right, otherwise, what I'm dealing with here is I'm dealing with a fork in the road, right? I'm looking at a card that could have a value of 1 or could have a value of 11, which means that the number of values that I currently have for this hand just doubled. Make sense? If I had, this was my second ace, for example, and I currently had 2 values, now I have 4. Right? Number of things doubled. Because what I need to do is I need to add a 1 to all my current running totals. I also need to go and add an 11 to my current running totals. So the first thing we need to do is we need to duplicate all of our current totals, tack them onto the end of our array, and then we go through and add a 1 to everything, and then we add an 11 to everything. The other thing we can do is we can add a 1 to everything, then duplicate it, and add 10 to some of them, half of them.
The only time we need it to be a 1 or 11 is when if we have it's less than, if the running total is less than 10.
Running total is, the only time you need to deal with 1 or 11 is when you're looking at an ace, when the value that we currently had came out as an 11, because the ace is the one special case.
Right, but if the running total is, if let's say we have a running total going, and it's at 10, and if we get an ace which is at 11, that adds up to 21.
Yeah, we could certainly do that. Yeah, what I'm doing right now is I'm not paying attention to the rules of blackjack. I'm coming up with all the potential values that this hand could have. The good and the bad ones, the ones that are over 21. So it's not 10, it's 21. So what you're saying is you could certainly be picky here and say, okay, my current running total is a 17. Well, the only one that makes sense is a 1. Because adding an 11 to a 17 doesn't work. Okay? I'm going to go ahead and I'm going to calculate all of them. And then what we're going to do is we're going to get rid of the ones that are bad scores. Does that make sense? It's easier to do that as a one, a one-off at the end. Anything greater than 21, ignore, than it is to try to do all the special logic in the middle. But you certainly could have. You could have said, I'm only going to treat this as a special case sometimes. All right, so we have to do something special here. We know for a fact that we're going to add 1 to all the current totals. Then we need to duplicate those and add an additional 10 to the duplicates, to the clones. Does that make sense? Okay. So what I need to do here initially is I need to go ahead and I need to give myself a temporary array. So a little array to hold on to all my current values temporarily so that I can go and put them back into our values in a few minutes. I happen to know how many values I currently have, right? I have num values, current values. That's how many guys I currently have. All right. So let's just say num values is currently 1. I have 1 running total, and all of a sudden, I hit a ace. What happens? Well, I'm going to take my current running total. I'm going to duplicate them. So this is going to be my temp array with 1 bucket in it. Then I'm going to add 1 to this guy, and I'm going to add 11 to this guy. Then I'm going to add the contents of this temp array onto the end here. So now I have my 2 different running totals. But now let's say this is my second ace I'd seen. So I actually have 2 running totals up here. So now what I'm going to do is I'm going to duplicate this, and I have 2 different arrays. The second one has 2 buckets in it. I'm going to add 1 to all the guys in the original array. I'll add 11 to all the guys in the second array. Then what am I going to do? I'm going to tack those 2 buckets onto the end of my other array. Does that make sense? So now I have 4 values that I potentially could deal with. So I had 2 different running totals here, and now 2 different running totals here for this new ace. Tack it on. Does that make sense? So I'm going to go ahead and give myself a temp array. So I'm going to say int array temp, and this guy is going to be a new int array of size num values. So however many current values we are potentially keeping track of, that's the size I want to make temp. All right. Then I'm going to go ahead and copy, I'm going to copy the values from my current array into temp. That is all the values from bucket 0 up to, but not including num values. And we're already in a for loop on I, so this is going to be for int j is equal to 0. J is less than num values, j plus plus, and we'll go ahead and say temp at bucket j is equal to values at bucket j. So values is a lot longer array, but we're actually only focused in on a little part of it. That's kind of constrained by num values, right? Then I'm duplicating that guy. So now I'm going to go ahead, now that I've done that, I've duplicated it. Then I'm going to go ahead and I'm going to, let's put a little comment in here. So let's say duplicate current values. Now let's add 1 to current values. So for int j is equal to 0, j is less than. We actually could have done it all in the same loop here. I'm going to keep them separate just to keep the logic separate, but we could have combined some of the stuff here. So j is less than num values. J plus plus, and we'll go ahead and say values at bucket j is equal to values at bucket j plus 1. So we'll go ahead and add 1 to all my current guys. That is me treating the ace we just found as a 1. So we'll add 1 to all those guys. Then I'm going to go ahead and add an 11 to all my duplicates. That is me treating this new ace as an 11. Add 11 to the duplicates. I could say num values because I know those would be, that's equivalent, or I could say temp.length. Temp.length will be equal to num values because temp was built in terms of num values. Okay? And we'll say temp at bucket j is equal to temp at bucket j plus an 11. So now I've added 1 to all my values. I've added 11 to all my duplicate values. Now I need to take all my duplicate values and add them to the end of my values. Starting at bucket num values and going up till the length of, going through the number of times of, num values, which is the number of things that are in temp. So now we'll say tack the duplicates onto the end of values and update num values. So I'll say for int j is equal to, there's a couple of different ways. Have I shown you a for loop that has 2 different counters in it? Okay, we'll do it this way then. So int pause is going to be where we are inside of temp. J is going to keep track of where we are inside of values. So we'll start j off at num values. We'll keep going as long as j is less than actually a couple different ways we can do this. Num values times 2. j plus plus. We could also have started j off at num values, kept going as long as pause is less than num values. Because we know that's the number of things we're going to have to use for this guy to go through temp. You could also say as long as pause is less than temp dot length. So pause is going to be the guy going through temp dot length. Num values, or j, is going to be our index inside of values. If you want to flip that array, we can flip that around. We could say index of values starts off at num values. This is probably the one that will make more sense to most of you. J starts off at 0. Keep going as long as j is less than temp.length, j plus plus. And then what we're going to do is we're going to say values at bucket index of values is equal to temp at bucket j. And then index of values plus plus. So index of values starts at the next opening inside of values, the next place we can put a value for our hand. We know that we're going through temp.length number of times. That's the new values that we need to tack on to the end. So j takes us through temp. Index of values started off already indented into values, some number of buckets, so that we can place in values at the appropriate offset, index of values, for example, the current value from temp that's now been adjusted. That make sense? Okay. So as of right now, when we say show values, we're going to allow ourselves to have up to 20 values inside of our inside of this guy, even though we know that that's more than we'll ever need. The reality is the next class we talk about data structures. We talk about linked lists that are arbitrary in size. So we're stuck with arrays right now. So the only kind of animals we know how to use are things that look like this. So we basically just had to create one that was big enough to hold the values that we wanted to hold. And then what are we doing? Well, we filled it with a bunch of zeros initially. Then we say, well, our hand is going to assume to only have one value unless we find some aces. Then we'll go through all the cards that are in there. If the current card is an ace, that's what this says, then go ahead and create a new array of the same size as our num values, a duplicate array. So then go ahead and fill it up with the old values. So now we have two arrays with the same exact hand values in them. Let's add 1s to all the old ones. Add 11 to all the new ones. Then copy the new ones onto the end of the old ones. Finally, we need to now update the value of num values. So num values is equal to...
Why are we copying the new ones to the end?
Because ultimately our array called values has to have the list of all the values for the current hand. So if our hand used to have 1 and we just found an ace, now that guy's going to have 2. But we got the 2 by saying, okay, well, here's our one hand, duplicate it, add 1 to this guy, add 11 to this guy, then put this guy at the end here. There's our 2 possible values for it. If we get our second ace, we had 2 values. Okay, duplicate it. So we have 2 values here, 2 values here. Add 1 to all of these, add 11 to all of these. Then tack those on up here.
So was that a growing array, or that's why you have 20?
That's why I have 20. Yeah, because our arrays don't know how to arbitrarily get larger in size. So I just made it big enough to hold all of our values. In the next course, we learn about something that will grow dynamically. So we need, after we've tacked everything back on, we need to increase the size of num values. It'll end up being twice as big as it was before. So we can either say num values is equal to num values plus temp.length, or we can say num values is equal to num values times 2. Maybe temp.length makes more sense just because we just tacked on all the values of temp onto the end of values. So even though they ultimately will say the same thing, we'll say num values is equal to num values plus the number of elements I just tacked on, which is num values. Okay? So then, at the end of this guy, after we've gone through all the cards and expanded our values so many times, then I can go ahead and say, here are the possible values for your hand. So we'll say display the possible values. Parent I is equal to 0. I is less than num values, because num values is the number of different values we might have for our hand. I plus plus, and let's put a little statement for system.out.println. And we'll go ahead and say system.out.print. And I'm going to go ahead and print out values at bucket I concatenated with a tab. So that'll give a value, then a value, then a value, then a value like that, so that they're all on one line. Okay, so this will go through all of the values that we've kept track of inside of num values and display the possible values for that hand. Okay, let's see if this guy works. So what we're going to do now is not just show our hand. We're also going to have our hand show its value. So let's go into Blackjack. So right here, we're showing the hand. Showing hand should probably also show our value. So we're going to go into hand here. And for show value, we could actually make this guy private. Private means he's only accessible inside of hand. And what we'll do is we'll always show the values as part of showing the hand. So showing our hand is down here. That's in display. So after we've displayed our hand, we'll say this dot show values. So that's part of what it means for a hand to display itself. A hand shows its cards and then displays the possible values. That makes sense? So let's see if this guy's given us the correct stuff. All right. I need to kick it down the line here after we've finished displaying that. Now it's on the line down here. Okay, so good. We got an ace right off the bat. So possible values for this hand are a 1 and a 6, which is a 7, or an 11 and a 6, which is a 17. So far, so good. All right, we'll hit yes. We want more. All right, possible values. A 1, a 6, and a 10, 17. An 11, a 6, and a 10, 27. Okay, now your suggestion is we should throw that 27 out. But a human being, we can think, and we can say, okay, well, if I'm going to take another card, it's not going to be based on that guy. Okay, so a human being can look at that and say, okay, I'm not interested in that one. Now, having said that, if you'd like to omit that, we can make a small change here and omit it. Let's just check our values here. I'm really looking at what happens if we get another ace. Okay, let's make sure that works for that. So far, so good. We'll hit yes again. Still not another ace. Numbers still look fine. Still not another ace. Still not another ace. Another ace should give us 4 values, right? Big money. This is a guy who busted a long time. Ah, got another ace. All right, so we have our 162 and 172. So those are 1 potential values. Now remember, this was 161 and 171 initially. Okay, so then this became a 172, so that was 161 plus 11. And this became a 182, which is a 171 plus an 11. That make sense? we added 1 to these guys after we duplicated them. So we had a 161 and a 171 twice. We added 1 to 161, giving us a 162. We added 1 to a 171, giving us a 172. Then we added an 11 to a 161, giving us a 172. And we added an 11 to a 171, giving us a 182. So this gives us, I think, the correct values. All right, now, if you do want to go your route and only show them values that matter, we can do that. So kill that program. So when we do show values here, what we're going to do is we're going to look at that current value and only show it if it's less than or equal to 21. So we'll just wrap this guy in a question. Remember I said it's easier to do it at the end, just to omit it. So I'm just going to situationally display the current value. So I'll say if values at bucket I is less than or equal to 21, show it. Now, one thing we might want to do here, though, is you could run into a situation where if you only didn't have any aces, you just busted, then it wouldn't have it will show 0 values. So we probably want to have a counter up here. Maybe int num shown, start that off at 0. Whenever we show a value, we'll say num shown plus plus. Then down here, we'll ask the question, if num shown is equal to 0, then let's do a system.out.print. Maybe like busted, something like that. And then this will kick it down the extra line. So this is in the situation where I have no possible values for my hand that aren't losing. So I'd like to show something. So if I wasn't able to show any values here because all of the possible values are over 21, let's give them the sad news instead of just a blank. Make sense? All right, so 3 and 13. Let's get some busts going on here. Oh, one of them was busted. That's why it's missing. See, your hack tricked me. I thought we introduced the bug. Okay, yeah. So only 13 is still kicking here. The other guy's already lost. So, am I good with 13? Yeah, let's keep cooking. I busted. So 13 plus the 10 for the jack is a 23. That's busted. So I've lost. That makes sense? So that's roughly our game. We can finally say that we're done. We can we can give them a feedback as to what the current value of their hand is. What will that be? It would maybe be getting the highest value of the hand, something like that. So one thing I can do here, I'll show you a little trick. So before we show our hand values, let's say arrays.sort values. So now values will be sorted from smallest to largest. So instead of having to write your own sort like merge sort or something like that, or insertion sort, this guy will just sort them. Usually implementations are using quick sort. Not really important. We've written our own sorts before, so if you need a quick numeric sort, this guy will do it. So we have a class called arrays that has built into it a nice little power tool called sort. I can toss an array of primitives to it, in this case an array of integers, and it'll sort it for me. So we'll go ahead and run this again. Oh, that's not going to work for us. Why did I get 2 zeros there? What kind of animal is values? Values is a 20 bucket integer array that I filled up with zeros, right? But I only keep track of I only keep track of the number of values I'm currently. So I probably have well, actually I currently have two different values in there, correct? I have a 3 and a 13 are the two values. So I had a 3 and a 13 in bucket 0 and 1, and then I had 18 zeros after that. Well, it just so happens that when I sorted that guy, I got 0 and 0 and 0 and 0 and 0 and 0 and 0, and finally the 3 and the 13. Yeah, so let's see. Will my sort let me do it backwards? Otherwise, we probably aren't going to be able to use this sort. Because it's okay if we do this in descending. That might even be better. Ooh, this is a better one. I can sort from an index to an index. So I'm going to sort values from bucket 0 to bucket num values. So there's my 18. Busted. We got to run this again. Give me another one. Killing me. See, your little add-on here has made this much more difficult to test. Oh, I'm going to bust right away here. Oh, that's pretty. So I have one busted hand and then the 21, which is my winning one. So we could stop them there, but technically in a game of blackjack, since your cards are private, you can ask for another card if you currently have a 21. You're stupid. You shouldn't do that. but I mean, it's not. I don't believe it's against the rules.
What does that take you?
Huh?
There's no point.
Yeah, there's a point losing money. If you're gambling and you've won, but you decide you want to lose, then you ask for another card. All right, so this guy appears to be working-ish. So I think this gives us our blackjack. This is pretty much solved our homework. Okay, so let me go ahead and give you the solution to this guy. I've just been pushing the whole thing up to GitHub, right? Is that what I've been doing? Haven't I been putting it on GitHub too? Last time I put it on GitHub. So let me go ahead and do that again this time, because we have so many different objects now, it's going to be harder to see on Slack. So CD, is it just Dropbox? Actually, let's cheat. I'm going to go here, then here, then here, here. Let's make sure that's up there. Yep, here's all our blackjack stuff. All right, questions, comments, concerns, bribes about blackjack. So not too bad. All right, so let's take, we've been sitting for a while. So let's take like 19 minutes. Let's take till 8 o'clock and we're gonna come back. I'm gonna start us on some Android stuff. Sound good? So stretch your legs, blah, blah, blah. I'll see everybody at 8.